to 2.3, vertical motion problems. Now we're going to be throwing objects up from a height. So when you throw objects up from a height, several things change, okay? Acceleration is always negative, but now why not is actually at the top of the cliff or the building or whatever we're throwing from. So imagine standing on the edge of the Grand Canyon and you toss a peanut up into the air, supposedly to catch it, but you don't. And it falls all the way down to the bottom. That's what we're going to look at. So when we throw a ball up from the height, the only main change in the calculation is that you have to find everything going up like you did for the beginning of 2.1, or I'm sorry, 2.2. Find time up, everything going up, because you're throwing it up, and then separate everything from time down, which is more like free fall. Okay, so notice in this diagram, y naught is greater than 0, v naught is greater than 0, time up is greater than 0, y is the ultimate height, the velocity at the top is 0, time down is greater than 0, but you'll notice it's not the same as time up anymore, and the velocity at the bottom is less than 0, it will be negative, and it is not at all the same as the velocity at the top. Now we have a new one, YD down here, okay? That would be the ground, the ultimate ground. So considerations, realize that when you separate up and down, there will have to be some linked equations because you can't find everything with what you're given. Variables to consider, you now do have what is that, 369? Notice that you also have a delta y. Delta y is y minus y naught, okay? So it would be the change in the cliff height to the ultimate height of your object. There are 3 primary situations, and I will make those individual little videos so that you know exactly what's going to be going on. 3 primary situations given v naught, which will be positive, and y naught, the height of the cliff, y naught and y, so the height of the cliff and the ultimate height, and y and time up. Now, there are several other situations, but those are going to be the primary that we're going to look at because a lot of the other ones are even more complicated. We try not to do that too. Okay, so here's an example. Nick, of course, is standing at the edge of his building 66 meters from the ground. If he tosses a jelly bean up with an initial velocity of 14 meters per second, how long will it take to reach the ground? Well, this is a situation 1 example. So you have a time up first. Remember that time is v minus v naught divided by a. So that your time up is 1.429 seconds. Then you can find the ultimate height because y is equal to y naught plus v naught t plus 1/2 at squared. Be sure to include the height of your building as your y naught. So plugging in the values, notice that your v naught is positive and your acceleration is negative. And this is a linked question because I have to use the time up that I just found in order to find the height. That does mean that you will have a double rounding error. So calculation, the ultimate height would be 75.990 meters. Then if we were going to find the time down, which it did ask how long will it take to reach the ground, I have to find time down using the ultimate height that I just found. So again, this is going to be a triple rounding error because I'm using a value of a value that I used. So this is the square root of 2 times 76 divided by 9.8, which is 3.938 seconds. Therefore, your total time up plus time down, should be 5.367 seconds. You're going to have 3 individual videos to watch next week. Thanks for watching.